Hey, welcome to the lesson on combining and simplifying expressions with rational exponents. The essential question for the lesson is how can we combine and simplify expressions that include rational exponents? By the end of the lesson, you should be able to combine expressions with rational exponents and also simplify expressions with rational exponents. We're going to use mostly the Common Core standard extend the knowledge of rational functions to rewrite in equivalent forms. Here are the properties of rational exponents, and they stem from the properties of exponents themselves. And so let's just go through and review those. One of them is that if you have two exponents with the same base and they're being multiplied together, you can just add the exponents. And so, for example, if we have a rational exponent 8 to the 1/3 and 8 to the 2/3, since they're the same base, we can add 1/3 and 2/3, and that is equivalent to 8. 8 to the first power, which is just 8. If you take the cube root of 8, which is 8 to the 1/3, you'll get 2. And if you take 8 squared and then cube root that, so 8 squared is 64, and then you cube root that, you will get 4. So you can see you would have 2 times 4, which would give you 8. So you can solve it both ways. This goes to show you that the property holds true. Now, another property of exponents that we can extend to rational exponents is that 8 to the m, if we have that whole thing being raised to the nth power, we can multiply the exponents. So if we have 5 to the 1/2 to the fourth, all to the 4th power, we can just multiply 4 times 1/2, which reduces to 4 squared. Or sorry, 5. We can multiply 4 times 1/2, which would reduce to 2. So we'd have 5 squared, and that would give us 25. Another property is that if we have a times b to the both of those raised to the m power, we can distribute m to both the a to the m, and b to the m. So here in our example, we have 4 times 5, both of those raised to the 1/2 power. We can rewrite that as 4 to the 1/2 times 5 to the 1/2, and we get 2 times 5 to the 1/2. Another property is that if an exponent is negative, we can rewrite that whatever's being raised to the power, only what's being raised to the power. So here a is being raised to negative m, we can rewrite that as 1 over a to the m. So for example, if we had 9 to the negative 1/2, it would be 1 over 9 to the 1/2, which reduces to 1/3. If we have a to a certain power divided by a to a different power, as long as the bases are the same, which they are in this case, they're both a, we can rewrite that as a to the exponents subtracted. So in our example, we have 7 to the 3/2 over 7 to the 1/2. Using that property, we can subtract 1/2 from 3/2, and we get 7 to the first power. And last but not least, if we have a over b and that whole thing is raised to the m power, then we can do that to both a and b. And so in our example, we have 5 to the 1/3, or sorry, 5 over 27, all raised to the 1/3 power, which would give us 5 to the 1/3 over 27 to the 1/3, which means cube root 27, you get 3, and 5 to the 1/3 is as simplified as it can be. Here we have an example that using just radicals we can't simplify because the indexes are different. So we can't just divide x to the third over x to the third and x squared. We can't just divide and get x. So instead, let's use rational exponents. So we have x to the 3/4 we convert to rational exponents over x to the 2/8. Now x to the 2/8 will simplify into 1/4. And if we use properties of exponents, since the bases are the same, they're both x, we can subtract the exponents. And so we'll get x to the 3/4 minus 1/4, which is 2/4, which will simplify to x to the 1/2. And if we rewrite that in radical expression, the square root of x is as simple as this expression can be, because we don't know what x is. And that's one way you can simplify using rational exponents. So how can we combine and simplify expressions that include rational exponents? Well, we can extend the properties of exponents, add, subtract, multiply our exponents in ways that we couldn't if we were using radicals, and then simplify, and if needed, rewrite in radical form. So I hope you can combine expressions and simplify expressions with rational exponents. Please copy this chart. Make sure you have this in your notes if you haven't done so yet. Pause the video and make sure you write this down. They'll be very helpful in your homework coming up. Go ahead, try your homework assignment. If you have any questions, reach out to me or another math teacher in the Math Cafe. And our next lesson will be solving square root and other radical equations. So we'll be taking radical and rational expressions, and we'll be solving equations now with them. Since we know how to simplify and manipulate them, now we can solve equations that have those types, those radicals in them.